Instead of having the pilot light burn all the time and using up all that gas, even when we didn't have a call for heat, we came out with the intermittent pilot system. So this is a conversion kit. If you had an existing standing pilot furnace, you could convert it to an intermittent pilot system, which is really cool because it came with a new combination gas valve, simply had on and off, and it came with this little control module, and it also came with our spark igniter. This also doubles as a flame sensor. What happened was we had our pilot light that would come out, and it would be in its existing location. But with this furnace, what you would do when you had a call for heat, it went to the control board first. The control board would then energize the spark igniter. The spark igniter would light the pilot light directly. It also doubled as a flame sensor for flame rectification, we'll talk about in another video, that proved that there was a flame. Once the flame was proven, the control board then energized the main valve and allowed gas to flow through the manifold to the spuds, through the orifice, mixing with primary air across the pilot light, igniting into a flame burning inside of the heat exchanger. So it was a really great modern times, and we would convert furnaces over. Nowadays, this is completely out of date with direct spark ignition systems, but this was a conversion kit for the intermittent pilot system. So there was two different solenoids in here. One solenoid was for the pilot valve, allowing the gas to flow to the pilot. The other was the main valve, allowing gas to flow to the manifold. You can see it's a brand new kit, still has the plugs. You had to check to make sure you had in and outs correct. It did have a pilot adjust, so you could adjust the pilot light, and this was your main adjust the gas pressure. So this would sit here and go tack, 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 until it finally ignited, and then it would sense a flame through that signal. We couldn't use a thermocouple anymore because it took too long for the thermocouple to energize, and it took too long for this control board to know for sure if it was getting that signal. So what it did was went electronic, and it worked really, really well. Now this was a conversion kit, but a lot of manufacturers actually installed systems with intermittent pilot straight from the factory. Carrier is one of these companies that did that. And what they had was their combination gas valve that was very similar. It had a main valve, a pilot valve, it had a main valve, it had a pilot valve, and the common. So we had two solenoid valves. One solenoid would open the valve to the pilot. So our pilot tube would be here, and this little Phillips screw was the adjustment for the gas pressure on the pilot valve. Then also, once we proved the flame, we'd open the main valve, allowing gas to flow through. This was our flame proving device. The pilot tube would go from here to this point here, up near the burners. The pilot would burn against this little strip right here, and this strip was bimetal. We have the three wires running through here. One was normally open and the other was normally closed. Once the pilot light burned against that bimetal strip, the bimetal strip would get hot enough and it would open the closed contacts and close the normally open contacts. This would go back to a control board, so the control board knew for sure that we did have a pilot. Once the control board knew that we had a pilot, then it would energize the main valve, allowing gas to flow through the manifold to the spuds, through the orifice, mixing with primary air into the burners, across this pilot light, igniting into a flame burning inside the heat exchanger. So this was our intermittent pilot system. It was the step between our standing pilot and an effort to save energy and make things more efficient. So we're going to dissect this intermittent combination gas valve. So if we take this cover off, we can see here we have two solenoid valves. This is our main pilot, or main valve, and this is our pilot valve. Now there's two separate valves. We'd energize the pilot first, prove a flame before we'd open our main valve. It was still considered a redundant valve. Gas actually inside of here flowed through this valve first before it could flow through this valve. So both had to be open before we got gas to our manifold. This was a never used combination gas valve in place. Now on this port here, this is what we use to adjust the gas pressure. We would unscrew this, and behind this safety plug there was the adjustment for the gas pressure. So we'd put our tool inside of here, and we would screw it in to increase pressure, and we'd back it out to decrease pressure. On this side, this was our pilot tube. So the pilot tube went to the pilot light, and behind this screw right here was the adjustment for the pilot. So we could make the pilot larger, or we could make the pilot smaller. So inside of here, we'd use a thermostat screwdriver to get to this flathead screw in here, and we'd screw it in to increase the pressure, bigger pilot, or screw it back to decrease pressure, a smaller pilot. Very simple little process. We also had our pressure taps here and a pressure tap here. So this says in, so this is our inlet gas pressure, and then if this is the in, this has to be out to our manifold, so this would be manifold gas pressure. we're going to do is continue to take this apart and take a look at what it looks like underneath these solenoid valves. These are special type screws. You're not supposed to take these valves apart. And if you do take it apart, you should never put it back into use. In the old days, we used to actually rebuild these combination gas valves. These new ones that are non-serviceable use special screws with a special tip so that you don't take it apart. If you do take it apart and try to save it, you're accepting a huge amount of liability. The reason they stopped allowing these to be serviceable was because in the old days, people would rebuild them, not do it correctly, gas would leak through the combination gas valve, through the gaskets, and it was causing fires, and some people got injured from that. So they no longer allow these to be serviceable. However, I found the key just for your learning experience. Take this last screw off here. What we're going to do is take this fitting, this whole entire piece off. Once we pull this up, and I tore the gasket, so another reason why they're not rebuildable. These were cork style gaskets, notoriously for tearing. But here's the plunger for a main valve. So the electromagnet would energize and it would pull this up and would de-energize the electromagnet, and the spring would push it back down closed. The little rubber seal here would seal across this piece right here. This valve had this little pin that pushed against here. This and the chamber caused the main diaphragm to stay closed. What we're going to do next is we're going to open that up so you can take a look at it as well. The bottom side is our pressure regulator. I always talk about this being a combination of a solenoid valve and the pressure regulator. That's how you're going to have to diagnose this. Do you have 24 volts to the combination gas valve, and do you have gas pressure coming to the gas valve on top of that? Now these intermittent pilots, they're definitely out of date at this point. I'd recommend replacing it with a direct spark ignition or a hot surface igniter or a 90+ furnace because they're so much safer, so much more energy efficient. But this is just for your knowledge and education and training. The more you know, the farther you can go. So here's our bottom plate. We have the spring that keeps the diaphragm pushed up, and once we pull this whole entire diaphragm out, all these pieces are going to come out together. You can see this is very fragile material right here. So this spring keeps this diaphragm pushed closed. Here's the other side of the small solenoid electromagnet, pushes against that, and this spring keeps that pushed closed. Once we pull that spring out, it's very simple. The solenoid is here, the main solenoid there, and here we have our screen. So our gas came in and goes through the screen. From the screen, it goes to the main chamber before it allows it to go to the next chamber that has our pressure regulator. From the pressure regulator chamber, it goes through here and then out to our manifold. Lots of tubing. Then our gas pipe tubing comes in as well. It's going to be very difficult to see it. It actually has its own filter as well. Let's see if we can get this out of here. It's completely unusable now at this point anyways. Let's just destroy it all the way. So this is the filter for the pilot valve, and lots of little tubing and chambers redirecting all of this combination gas valve to all the solenoids, all the different controls. It's really hard to see how it flows through here, and with the books you can actually get a better idea of how they flow. Cut. Now this particular combination gas valve has a special name. They're called smart valves. There's two different manufacturers that made them, Honeywell and White Rogers, but both these worked very similar. There was different modifications and times with them, but they required a little different steps for servicing them and diagnosing. We had our main IFC, plus also behind here there's another little control board in this as well. So they make this little cool tool that you can hook up, you can plug in, and you had many different options for what size you need. And so you would match up the model number of the gas valve to one of these little cards. In this case, this is a valve SV950, so we're just going to slide this little card inside of here. And then we have to find the right plug adapter. So this little plug adapter is going to fit onto the top section. And it's got this nice handy little hook, so I can just hook it here next to the furnace. Now I have to put this in series on this system. So I have these two plugs, so I find that plug right here, and I just unplug it. This is the igniter, and what I'm going to do is put this fitting into my valve, and then my igniter is going to plug into this component here. I have another plug, it's this little square terminal back here, and I'm going to unplug it as well. And with this little square terminal, we're going to plug it in to my component, my meter. And then I'm going to plug this last one back into the smart valve. And then have to make sure that I have my ground hooked up as well. So I'll hook the ground up. Never ready to have a call for heat, so we can actually go through the process, and this cord is going to tell us if we have 24-volt power. It's going to tell us if we have the correct polarity, if we have ignition, if our main valve ignites, and if we have our main fan motor running. This is an older model, so it's very simple as what it provides, but some of the other models will go through and provide us with a whole lot more options, including they'll give us the reading for our flame sensor. So I've already jumpered R to W, so the thermostat calls for heat. It connects R and W. I've already jumpered that with this jumper here. So now as I close this door safety switch, we're going to start our sequence of operation for this gas furnace. Now this furnace is designed for natural gas. I do not have any gas here at this building, so I have it modified on propane, so it will not run right. It's actually dangerous to do. Don't run it at home. Also, I don't have my flue pipe hooked up. I have a big vent fan set up to get the carbon monoxide out of the way, but that's also quite dangerous. We're just going to run this for a short period of time so you can see the operation of this furnace. So we're going to have our call for heat. Inducer fan first. Pull it back into the pressure switch. We lit our pilot light. We're going to show this shortly at a close-up. Now the pilot light, we lit the main. Pulls it back into our pressure switch. We hear a little bit of gas. We see the pilot light burning right there. Now we ignite the main burners all the way across. Now the color of these flames is improper because it's burning on the wrong gas, the wrong pressure, and the wrong orifices. But you can still, this is one of the earlier models of the smart valve, but it still works the same way. This port here is also the same side as our inlet gas pressure. So we could actually put a manometer here. We'd shut our gas off. We could put a manometer here to see if we had the correct gas pressure coming into the system. Also, if we notice on the back side of this, there's two different screws right there in the back side. We take that cap off, and behind that's the adjustment for a gas pressure for a manifold, and this is adjustment for the gas pressure for the pilot, for the intermittent pilot. On the other side, we're going to move our little meter out of the way. You can see our pilot tube that's coming out, as well as we have another port right here. This port is going to be for our manifold pressure. We take that port out, we can put an adapter in there and read the manifold pressure. This should be at 3.5 inches of water column for this gas furnace, which is noted on the combination gas valve. Actually, I stand corrected. This one is 3.2 inches of water column as a range between 3 to 5. So this is where we're going to set the manifold gas pressure. This is our pilot tube. Now, if we want to shut the furnace off, something's malfunctioning, not working right, we can turn this to the off position, or if we need to get a better look. So in our burners, we were talking about earlier these crossover tubes. You can see this little split right here. This allows it, once we ignite our burners, it allows it to go across through to the next burner, ignite it, and so on. So these are little crossovers, but this section right here is our intermittent pilot assembly. Here we have our pilot tube. Inside of here is going to be an orifice just for the pilot, and this is the pilot burner. It directs how that flame is going to burn. Right here is our miniature hot surface igniter, and right here, this little bitty rod is our flame sensor. It's our miniature flame sensor, and then this is our ground part here. So when the pilot's burning, it's burning across that flame sensor, and that flame sensor, it allows it to have flame rectification. In other words, the flame becomes a switch, and as the flame conducts electricity through this rod to the ground, it makes it go into a pulsating DC signal that's quite unique that the control board reads. So we're going to plug this furnace in. I got it wired up to where we can see the hot surface igniter happen. Now I can't have it to where the pilot lights, because if the pilot lights, then the main burners would light right afterwards, and that would burn up the camera, and I would be in a little bit of trouble. So we're going to go through our sequence of operation, have the thermostat call for heat, connect R to W, inducer fan runs, pull the vacuum to the pressure switch. Now we can see that hot surface igniter getting hot. It's turning bright red, and it gets so hot that we should be able to touch a piece of paper to that, and it just instantly catches it on fire. So it is a hot surface igniter. Now these are very fragile. If you look at these wrong, they break. So you got to be very, very careful if you're working on this type of a furnace. So from this angle, we can see our combination gas valve, or what they call smart valve. This is our dial where we had off and on. So if we wanted to leave it in the on position, we would have to turn this dial so that way everything could actually light up. This plug right here is the plug for our hot surface igniter and flame sensor. So the two blue wires is for a hot surface igniter, the single wire is for a flame sensor. And there's simply a little plug on the side, little keeper. We push this keeper in, and this just unplugs, and we could replace that. On this side here, this is our incoming, where a gas line would come into this. And right here, you see this little shiny port. If I was to use my screwdriver here, we could unscrew this port. And this allows us to get to our adjustment for our gas pressure. Remember, this is a combination gas valve, a combination of a gas valve and a pressure regulator. So if we zoom in here, you can see this component right here is what we'd use to adjust the gas pressure. You would put it in that plastic piece, and if you screwed it in, it would increase gas pressure, and if you backed it out, it would decrease the gas pressure. On the side port here, that was usually for our pilot assembly, so we could adjust the flame on our pilot assembly. Also, you see here it has our PSI. This is our inlet. This is the adapter where we can check the gas pressure coming into the gas furnace, and we want to check that static and while it's working. We have a tool that we use for that. It's the same tool we use for our AC. It's our service wrench, and that same adapter fits into that, and we'd set this to be loosened. This is the plug that comes out, and what we have with this would be open. So if the gas was on while I did this, gas would be pouring out. So you'd have to shut the gas off. You would put in this little adapter right here. Once you have your adapter, you could put your hose on this to your manometer, turn the gas back on, and you could check your gas pressure. Then you started the system up, you could see what your incoming gas pressure was. Sometimes we'd have a furnace that would be running fine by itself, but if the water heater or stove was running, we wouldn't have enough gas pressure coming into this system. We'd have to remember to shut the gas off, and then we would take this piece back out, and then we would have to put this port back in where it was, otherwise we'd have gas leaking out. On the other side is where we see our output port. So this port right here is very similar to what we saw earlier. This port is going to be the manifold pressure. So the manifold is coming out on this side. We would unscrew that with the same exact tool. We put the same adapter in there, and this way when the combination gas valve opened, we would see what the pressure was in the manifold. So this port is giving us the same pressure that's in this manifold. On the back side, we also see this tube right here. This is our pilot tube. So this is what's sending gas to that intermittent pilot. And then on the side as well, this is what's going to our control board. So the control board communicates to this, and it's just simply a square plug. We have a little keeper on it as well. If I just press that little keeper, this unplugs, and we have the 4 wires on this. So it's quite a simple little control, but inside of here is also a separate control board. Just plug this back in. It was very important when you did maintenance, you had to make sure that you put this plug back in, that you put this plug back in, and also you didn't lose the little cap for the pressure regulator. So this cap had to be on, otherwise you could be leaking gas out of this port right here. It was also important that when you left the customer, before you left the customer's house, you had to use a gas leak detector, an electronic leak detector, or you would use soap bubbles or both to make sure it wasn't leaking. What I used was an electronic leak detector, and I would have it running the whole time I did service work. So my electronic leak detector would look something like this right here, and it had this end piece on it, and it was just a sniffer. It's flexible end, and when I turned this on, I would sniff all of the components with this tool and smell for any kind of a gas leak. Soap bubbles has worked as well. You can put the soap bubbles around there, but you want to make sure you use a specific type, because regular plain kitchen soap could have a corrosive effect on some of this aluminum. So you had to make sure you use a specific gas leak detector set up for natural gas, designed for that, and all the supply houses carry that. So we talked about this smart valve that had a control module on the unit and another control board inside the valve itself. At the time, I didn't understand how that works, so I bought this tool a long time ago and spent a lot of money on it, as well as other adapters for other units. But when I got to reading more and started learning the importance of reading, the book actually has tons of information about how to diagnose and how to check these components without having to have this expensive piece. So I recommend you start getting into reading, learning about how this stuff works. These videos are a great way to start, but there's so much information in these books. That's where this one's at, and tons of stuff you can learn from. And keep reading. I'm not somebody that likes reading